Hi everyone, this is Dr. Swaminathan. Now we are going to discuss about the case study test benches and with the examples how we are using the test benches for the following examples, that is in the Verilog HDL coding. So the outline of today's class, we are going to discuss about the test benches, full adder, structural, behavioral. Following into the activity, we will see the examples, how the test benches or how the coding, Verilog HDL coding is running on the Xilinx tool with the helping of test benches. That is the case study of today's topic. Like we will see the following examples: decoder, equality detector, comparator, priority encoder, full adder, ripple carry adder, and the D flip flop. So first the test benches means following test benches we are using that inputs. We need to apply the inputs using our test bench. So we have created the input based on our convenient and apply into the design module, and based on this we can observe the outputs. That is called the test bench. So here we have the example: time scale 1 nanosecond, 100 picosecond, and the module called top, and register PAPB, that is wire P sum or P carry, and the half adder we are using G1 PAPP and P sum P carry. And following with the initial begin, it starts with the label and register 2 colon 0, that means 3 input register, and for the for loop is begin, I is equal to 0, that is the initial statements. And next we will see the PA or PB is equal to I, following to the display the value of the PA, PB and P sum carry for end loop, and we are using for first loop, and again the initial for another end, and totally the module is end. And next to the test benches, we will see the initial begin. The clock is equal to 0, hash 50. That means, look at the diagram, timing diagram. From 0 to 50, the clock value is increased to 1. So, hash 50, clock is equal to 1. Again, it creates after 30 seconds. So, 50 plus 30, 100. So, hash 30, clock is equal to 0. And again, it goes to downs, that is clock is equal to 0. Again after hash 20 means 80 plus 20, 100, the clock value again it increases. So this is called the consequence of the value based on the coding. And next the repetitive signal 0, 10, 20, 30, 40 means it between the difference 10, it increases 10, 10. So a simple solution for wire clock, assign hash 10 clock tilde clock. That means clock value is reversed based on the hash 10, that is 10 seconds. The caution that the initial value of the clock wire data type is equal to Z. So the tilde symbol Z is equal to X, and tilde X is equal to X. And initialize the clock signal, that initial value begin, the clock is equal to 0, it end. So the caution, the clock value of the wire cannot be used for the initial statement. So for the solution, we can use register clock or initial begin, and the clock is equal to 0 for end, always begin hash 10 clock tilde clock. That means forever loop can also be used to generate the clock. And next Verilog module example, RTL versus structural. So the module full adder behavioral Verilog, it makes the input x1, x2 and c in, and output s comma c out. So it means register 1 is to 0 temp, that means register value is 2 bits, and always at hash that we are using the begin. So temp is equal to 1 bit 0, that means 0 value comes means it added the value x1, and again x2 plus c in. And again assign s is equal to temp of 0, so we are creating the temporary value of 0, and again it creates a temporary value 1. So we can equate the temporary value of 0 is equal to s, that is sum, and temporary value 1 with c out. And again the test bench, we are creating the value for a is equal to 0, 0, 0, 0, 1, 0, 1, 0 between the hash 5 values. That means 5 seconds difference, we are creating inputs values, and based on this we will use that test fixture for the full adder. Look at this module test fixture, and register a comma b comma c in, that means register is created for a b c in input value, and wire, that means output sum carry. For the adder, u naught is the label, carry sum is the output, a b c in is the input, the initial begins, and the monitor the value between the a b c in and sum carry. and asked to define the first of all A, B, C in everything is 0, and again it increases one by one and it will finish. So this is the first full adder, and again the adder, full adder, another module. That means we are creating the module adder carries sum A comma B comma C in, and the output carries sum. So the input value ABC in for the wire W0, W1, W2 for XR U0 means U0 is the label, sum is the output. So A XR B XR C in is equal to sum. And same thing for AB plus B in C in A. We are creating the U1, U2, U3 for the label. And again we are creating the another label U4 for making this carry value by adding this W0, W1, W2. So this is the example of full adder, and again the module we are using the XOR and OR gate like this. We are using the test fixture module for the structural module, and again we are making the structural module coding for the inputs value, different values we are creating. Then the mixed modeling means both the combination, that is data flow modeling, behavioral modeling, and the built-in primitive, that is structural modeling. We are combining this three module for the mixed level modeling, and also for this module also we have in making that test bench for this mixed modeling style like this. And following to the activity debate, we will discuss about the decoder level. So decoder means the commonly uh, that values n is to 2 power n that we are given. So here we are using n values 3, and 2 power 3 means 8. So we are creating the input output value, and based on this we can make the loop for the 8 bit. So 0 first initialize, everything is 1, and again if the value is added, that is 0 0 based on this 3 bit 000 means that means 8 bit 4 ones and triple 10, and again double 101 and 1011. The 0 value diagonally it can come, and after that the default it gives 8 bit tick, that is X is nothing but don't care. So this is the 6 examples of the decoder, and again the priority encoder, based on the priority we can give the output, that is called priority encoder. So look at this. First inputs value, that is no 0, so that value is no 0. So X, Y, that is don't care, and Y is a 0 value comes. Again 1 0 0 0, so D not only 1. Look at this last from the last line to the third line, fourth line, else if D not is equal to 1, then it makes the 3 bit 001, that is the output. Same thing we are making the all the above D1, D2, D3, everything is we have created. And again the full adder, ripple carry adder. Ripple carry adder means that carry will be rippled together. That means look at this diagram. First carry output is given as a second up to last one. That is called the ripple carry adder. So here we are using the ripple carry adder. We have making this implementation of the full adder with the ripple carry adder. Look at this. First we are writing the full adder coding. Again we are implemented the full adder coding using that value. So look at this ripple carry adder program. Here we are using the full adder U1. That means that full adder is implemented inside this ripple carry adder. That is the concept. And again for this making this comparator and D flip flop, we have making the comparator module comparator large equal less A comma B is the input, large equal less is the output, and AB is the input, that values of 4 bits, and large means A greater than B. If equal means A equal to B, less means A less than B, that is comparator. D flip flop means it works as a negative reset or positive edge clock. If reset means everything is resetted is to 0, else it gives the output. So D flip flop means delay flip flop. Based on the delay, it comes as output. So D out is came as equal to D in means with the some delay. Okay, or based on the reset value or clock value. So this is called the assessment, write the test bench for behavioral model, and write the Verilog HDL, that is the application or case study of the Verilog HDL for the 6 programs: decoder and priority encoder, full adder, ripple carry adder, comparator, D flip flop, everything. So this is the application or case study of the Verilog HDL. Thank you.